Hi everyone, welcome to another NLP Insider live show, and thank you so much for joining us today. We are here live every other week for 15 minutes to talk about everything NLP with industry leaders. I'm David Talby, CTO of Stochastic Labs, and today I'm excited to chat with Joel Lehman, researcher at Stochastic Labs. He was previously a research scientist at OpenAI and the founding member of Uber AI Labs. And today he'll tell us more about the evolution of algorithms through large language models. Welcome, Joel.
Pleasure to be here. Thanks for having me, David.
Great to have you here. So let's jump right in. So you've worked at Uber and OpenAI, and you're an assistant professor at the IT University of Copenhagen. Can you tell us a bit more about yourself and your exciting background?
Sure, yeah, I've been in artificial intelligence research now, I guess, for about 12, 14 years, something in that range. Started in academia and was working with neural networks that were like, I don't know, 10, 15 units, 20, 30 connections. And so it's been a crazy journey to now we're dealing with like millions, sometimes billions of parameters. Yeah, so it's pretty crazy. And I made a transition from academia to kind of industrial labs. Was at this company called Geometric Intelligence that got acquired by Uber, and then Uber to OpenAI. So it's been kind of a whirlwind tour of both academia and industry. And yeah, machine learning is in a very interesting place right now.
Yeah, it's a fun time to be in the front lines.
Yeah.
So you've done a lot of research in machine learning and have recently focused on large language models. For those less familiar with the topic, can you explain what a large language model is?
Sure, yeah. So we can just break it into the pieces. So they're called large because they have lots and lots of parameters. And there's been a trend over the past couple of years to keep scaling up the number of parameters in the models. They require more GPU memory, they require more compute. That's the large aspect. And one interesting thing there is that the larger these models they get, the better they tend to generalize, which kind of goes a little bit against some of the received wisdom of the past. But just we're living in an exciting time where we're discovering new things, and larger is better. And the second part is language models. And so a language model is a model of some kind of language, words or tokens. And the one kind of popular paradigm there is something called an autoregressive model. There's lots of different ways you can model language, but autoregressive model is the idea of taking some bit of text as input into a model, and then from that bit of text predicting the next word from that, most likely next word, and then the most likely next word from that. It turns out this is a really powerful paradigm. You can phrase a lot of natural language tasks in this way. And so there's been a lot of excitement about training these large language models that basically can have some understanding of language on big data corpuses, like scrape of the entire internet. And what's kind of cool about that is you can get this model to have a kind of a basic understanding of a wide range of human topics. And as a result of that, it's a really good foundation. Sometimes things are called foundation models. It's a really good foundation for jumping off to whatever kind of natural language task that you might want to specialize on. So there's a lot of excitement about these things. It's a big kind of trend right now in the field, and I'm sure that you may have encountered this topic before, but hopefully this is a little bit of an explanation about how they work.
Yeah. Thank you. So what are the benefits and the common use cases of large language models today?
Yes, there's many different use cases. So it just turns out that there's a lot of tasks that we can actually phrase in terms of natural language. So a popular kind of paradigm is something people talk about zero-shot or few-shot learning in the context of large language models. And what this means is for a lot of these language models, you can give a couple examples of the task that you care about, as long as it can be phrased in natural language. So like a classification task of natural language, code completion, like writing programming code. There's a lot of range of things you can do, as long as you can kind of give a couple examples of the thing that you want it to do. And then the model may be able to generalize to that task, or you can fine tune it if you have more examples. But there's been a lot of progress across lots of different tasks, like translation. It's hard to name all of them. I think continually finding new use cases for these things. And oftentimes, yeah, just anything that's kind of in the natural language space, state of the art will probably be by some kind of language model at this point.
Yeah, agreed. So Yes, I agree. I mean, it's very hard to, yes, to just actually enumerate the use cases, yes, and we're still discovering more. So your recent work is on evolutionary algorithms that use language models to generate new data and to then bootstrap language models into competence in a new domain. So can you explain the idea and give an example of how it works in practice?
Sure. Yeah. So I guess like a class of algorithms that kind of a lot of people learn about in maybe an intro machine learning class, but then maybe never touch again much are things called evolutionary algorithms. And I'm really fascinated by them because they are in nature, this really powerful algorithm. It's kind of inspired by nature, and um, yeah, created all the grandeur of and the diversity of life on Earth. It's just amazing algorithm. And they found a little bit to the wayside in some sense, compared to just how much progress there have been in other algorithms, like the language models that we're talking about. So this work was trying to bring those things together. Could we have an evolutionary algorithm that's driven by a language model? And basically, there's a way to kind of get a language model to suggest changes to something. So evolution is often about how do you get new variety from something that already exists, like a mutation, like something new from something old. And so it turns out that language models can be used as a powerful engine of variation. And so this is a way that you could kind of iteratively search for a possibility. You start out with something like a fragment of text or fragment of code in our case. So in this paper, we work with programming, like just working with Python programs and evolving Python programs. And so you have a piece of code, and it turns out you can suggest a change to that code and kind of iteratively search and refine that program to get better at some task. And that's kind of like the approach in a nutshell. It's kind of like, can we use these language models as something to drive an evolutionary search? And the hope is that you can get sometimes further by iteratively improving something, as opposed to just asking a language model to output it all in one go. I forget the other parts of your question, but I'm happy to address them if I forgot
Sure.
anything there.
So you use a language model and you say it's a piece of code and you say, initially you just say, just try something new, right? Because the goal is you want to propose alternatives, right? And see which one is better. How do you measure which of the mutations is better?
Yeah, so in this case, you're depending on some measure of quality that you already have. So in the domain that we used in our paper, we had a kind of an easy measure of quality. We were actually evolving Python programs that represented little, you could say like it's almost like a reinforcement learning task, like robots that would ambulate, and they're represented by Python programs. And so we just measure how far, in the simulator, we'd measure how far they go. So in practice, if you want to apply this to another task, you need something, a different measure of quality. And there are other measures of quality you can imagine having, such as one you might get through kind of like the we might call it the log probability of a sentence or of a phrase under the language model. Like that might be one kind of measure of quality. Like how good is the language model itself think that this answer is at meeting a goal? And there's other things you can do in that space, but might require some more thinking. Like another measure might be if you had examples from your task of good and bad examples, then you can learn like a classifier between those things, and that classifier could serve as the measure of quality that you would use to measure whether these variations you generated were good or bad.
Okay, and then once you think you have better examples by whatever measure you use it to tune the original model, the language
That's right.
model?
Yeah, that's right. So kind of like another wrinkle here is that the aim of this was kind of synthetic data generation. And the reason why we use this kind of ambulating robot task, one reason was kind of visually appealing, but the other reason was that it was something that we kind of made up. And so there would be no examples in the language model's kind of experience of this new domain. So we kind of introduced a new domain so that we could see if we could bootstrap a language model into some level of expertise in that domain. And the particular evolutionary algorithm we used, it wasn't just searching for better things, but also was searching for a wide diversity of things. So it's what's called a quality diversity evolutionary algorithm, looking for both quality and diversity. And so this way, you might give it one example to start from of kind of like one of these Python programs that represent one of these robots. and then it will measure not only how good a new suggested program is, but also if it's different than ones that are in the past. And so the aim of the algorithm is to kind of spread outwards and accumulate kind of a large data set from this initial example. Just one example, diversify outwards, keep making tweaks and changing it and increasing, if possible, the quality of these things, so that at the end you have a big data set that you can then fine tune a language model on. So now that it originally didn't understand this new domain, but now that you have all these examples and you fine tune on it, now it can actually understand more what's going on in this domain. And so it's kind of, not only is the language model kind of benefiting evolution, so you have the language model is enabling this new kind of evolutionary algorithm, but the evolutionary algorithm is also going to be able to help the language model by giving it more data.
Yep. So very similar to a human, right? So one human experiments, and then you go back and you teach your kids how to do it, right? And hopefully they have a better starting point in life.
Yeah. Or another way of saying is like kind of like, these processes that kind of keep creating new and different things. We're kind of familiar with those kind of processes in our daily life, like science itself is about this kind of process of kind of like finding new things, and the new scientists of the next generation will know more than us because there's more training data in that sense, and then they will actually create more training data, and we keep branching out and discovering more things. That's how machine learning research itself works.
Yeah, all research. Yeah, very interesting.
Yeah.
So you'll be presenting a keynote about evolution through large language models at the NLP Summit next week. What can the audience expect from your talk?
Yeah, so we kind of already teased it a little bit here, but kind of describing this evolutionary algorithm, and in particular highlighting how there's a different way to train a language model called a diff model, which is about kind of how you get a language model to produce changes. And we'll talk about that and about this algorithm itself and kind of where we see this work going.
Okay, very interesting. I mean, I personally definitely look forward to it.
Yeah, I hope so.
So, thank you very much for joining us today. It was great talking to you and learning more about really new ideas in large language models. And I agree with you, we're very early days there, right? So there are definitely many more approaches that I think we'll see, right? And it would be really interesting to see, right, what works, what gets adopted. Yeah, so everyone, please join us at the NLP Summit next week from Tuesday to Thursday to hear Joel's keynote, as well as more than 50 other technical sessions and keynotes, and as the largest gathering of the applied NLP community in the world. So that's happening next week. Registration is free, and we'll share a link to register here. Yeah, other than that, Joel, look forward to talking again next week, and thank you very much, and good luck with the work. It's very exciting.
Me too. Yeah, thanks again for having me. It's been fun to chat with you.
Thank you.